covered in smog and pollutants. Now picture a world in which the ozone layer is burned away completely. We would be vulnerable to the harmful rays of the sun. Fossil fuel has been proven to be harmful for the environment, yet we continue using them. Solar energy, at a contrast, is much cleaner than fossil fuel. It becomes much more cost efficient than fossil fuel. And unlike fossil fuels, we don't need to worry about the solar energy running out.
All right. As my buddy Jose stated before, fossil fuels cannot remain the dominant source of energy because they will eventually run out, and they're causing irreversible environmental damage, and they're also very costly to extract from the earth. Solar energy is very attractive as an alternative energy source because its abundance, the fact that it's environmentally clean, and how easily accessible it is. The storage of solar energy has been around for decades, but the receptacles used for it are very expensive and very brittle. To install solar panels on an average size American home, it will cost about $14,000. Also, the receptacles are typically very inefficient. Solar panels, which are the most common receptacles, are only about 10 to 20% efficient in capturing solar power. Energy produced from a solar power plant costs on average 3 to 6 times more than energy produced from coal. We need to come up with more efficient and lower cost ways of collecting and storing the sun's energy to make solar energy a practical alternative energy source.
One solution is more research into plastic solar cells produced from organic semiconductors. These cells are lightweight and flexible and can be produced in high volumes, though most importantly, they're cheap. While currently not as efficient, they have a broader range of uses, such as portable electronics or integrated into building, materials, and fabrics. Plastic solar cells can even be painted onto surfaces and products, allowing for a variety of applications. The plastic material is durable and cannot be broken as easily as conventional solar cells. This increases the lifespan for practical uses. Another promising application of the plastic solar cells is to use nanotechnology to collect and contain infrared light that can be used to harness the sun's invisible rays. A limitation of conventional solar cells are they can only harness the sun's visible rays, which is about half the sun's radiation and energy produced. This increases the theoretical maximum efficiency when combined with 2 solar cells, allowing energy to be generated even on cloudy days. Another large limitation is also storing the solar energy collected for use at night and on cloudy and rainy days. Today's batteries, like lithium-ion and lead-acid batteries, are costly, have limited lifespans, and have about a 15% energy loss when storing. However, heat energy storage is another viable option that is currently more efficient than electric storage. Many companies are starting to use molten salt, an inexpensive salt solution that absorbs considerable energy when melted and gives that energy back up when they freeze. By storing energy this way, there is only a 2 to 7% energy loss.